So ramps can be quite a difficult um, thing to implement into a pygame because there are no triangular hitboxes in pygames. So when working with triangles, it can be quite hard uh, to adjust the player in collisions with them, all that stuff, because there are no hitboxes for them. So they can be quite intimidating. Um, However, when broken down into smaller chunks, they can actually be quite easy to implement. Um, we're gonna pretend that this is the player, right? That is awful. I don't know why the R is so big. Anyways, so this is the player, right? This is the ramp that the player is going up, and then the red box is the hitbox of the ramp. Quite ultimately, when the player is trying to go up a ramp, you take the wall of the player's rect that is furthest into the hitbox of the ramp, and you take the furthest away side of the hitbox of the ramp. So if you're going left up the ramp, you take the left side of the player and the right side of the rects for the ramp. And then if you're going right, it's just switched around. You then let's say that this is 105, while this is 97. So that's their positions on the x-axis. Firstly, to calculate where the player should be, you take the difference between them. So that's just 105 minus 97. And then to work out where the player should be, you don't actually have to do anything with the x-axis other than find the difference. It's all with the y. Basically, what I'm saying is that the distance, how far you. This is under the assumption that we're working with a perfect right angle triangle, which is a perfect half of the tile. Um, um, you set the y equal to um, the bottom of the ramps rect minus the difference. So how far in you are into the ramps rect on the x-axis, you're equally that far in on the y-axis as well. So the further in you go on the x, the higher up you go on the y. The further away you go, the lower you are on the y. So that's generally how it works. So we get the difference, and then we just set the bottom of the player's rect. So p rect dot bottom. So the bottom of the player's rect is equal to the bottom of the ramp rect, which we'll just assign to RTB, and then you minus that from the difference. Really bad handwriting, but I'm on the mouse, it's quite hard. So that's basically what I do. And then if you're going right up a ramp, you just invert this. Ultimately, you, instead of using the left side of the player's rect, you use the right. Instead of using the right side of the ramp's rect, you use the left. Then when going down a ramp, you don't really have to worry about anything on the x-axis. You worry about stuff on the y. You kind of apply the same logic when falling onto a ramp and stuff. I'll just show you in code, but that's the general basis of what you have to do to go up a ramp. So the how far how far in you are into the ramps rect, you are equally as high as far in as you are in. So it's all kind of synced together in terms of distance into the Rex hitbox. So here, you've got the so that means the right ramp. As I was just explaining, the left ramp will go with the right. So if you're going right up a right ramp, you set the bottom of the player's rect equal to the bottom of the ramp rect minus the difference, or minus how far in you are into that rect. So, and then for left, it's just inverted. So you do the right of the ramp's rect minus the left of the player's rect instead of the other way around. And then when going and then on the y-axis, you basically just kind of do the same thing, except you just change the velocities over to the y. So you check whether you're going up or down. If you're going down, you set the bottom of the player's rect as you would when moving right up a ramp. If you're going up, I mean, that's only if you're on a right ramp. But if you're going down and you've hit a left ramp, then you do the same as you set the bottom of the player's rect as you would when you're going left up a ramp. You don't need to check if you're actually moving upwards and hitting a ramp unless you're deciding to implement ramps like these two. I'm not. I'm just sticking with these because I don't know. I feel like implementing these would just the time it would take me to do it wouldn't really be worth it. But when using this logic in a game, did not mean to do that. Oops. You actually quite nicely go up the ramps. Now, as you can probably see, there is a problem, and the problem is just that. Oh, am I recording, by the way? My game keeps like freezing up a bit. I'm using the wrong encoder, but I'm going to change it after this. But as you can see, I'm not perfectly on the ramp. This can be quite hard to adjust. You can just minus the Y of the player. But they'll always be kind of like 1 foot off of the ramp. I suppose maybe you could try, rotating the player, but that would obviously be more work, and I don't think it would actually be that worth it. It would kind of look quite weird. But yeah, I definitely need to change the encoder on my thing because it keeps freezing up. Anyways, so yeah, that's pretty much it from me, to be honest. I have nothing else to say.